Next example of the type dx by p, dy by q, and dz by r. So the example is dx divided by x square in bracket z square plus x into y, dy divided by minus yz in bracket z square plus x into y, and dz divided by x cubed y. So consider the first two fractions, first two ratio, that is dx divided by this and dy divided by this, and then z square plus xy, it cancel on both sides. Z is also cancel, and therefore we have the value dx by, this is not x by, x into z. This is x into z. Z and this bracket it cancel, and therefore dx by x is equal to dy by minus y, and therefore after integrating we have log x. This is in variable separable form. So after integration we have log x is equal to minus log y plus constant of integration. Suppose log c1 dash is the constant of integration, either add c1 dash, and then shift this minus log y. So log x plus log y is log x into y, cancel log of both sides. So we have the x into y is equal to c1. Either write c1 dash is equal to c1, right here c1 dash as or c1. So we have x into y is equal to c1 is the first solution of this given differential equation. Then consider the next two fractions, that is dx divided by this, that is first fraction, and the last one dz divided by x raised to 5. This is x raised to 5 into y. And then we have this, that dx divided by substitute this x into y as c1, x into y as c1. This x raised to 5y is expressed in this form, x raised to 4 in bracket x into y. Okay, and then substitute x into y is equal to c1. That is, use the first solution of the differential equation to obtain the second solution. So the sub method of the method number one. So the basic two methods to solve the differential equation, these are the two methods, method number one and method number two, and this is the sub method of method number one. What is that? When one integral can be obtained by this method and the second integral or the solution is difficult to obtain by this method, then non-integral can be used to obtain the another integral or another solution. That is, if you find the first solution of the given differential equation, and in order to find the second integral or second solution, we can use the first solution. So here the first solution is x into y is equal to c1. So x into y is equal to c1, and then substitute here x into y as c1, and then what we have c1 x cube dx, and that is a y variable. So x here is also x into y as c1, and therefore this becomes a differential equation in two variables. So dx and dz. So there are only two variables x and z in this differential equation. So cancel the third variable y by using the first solution. That is, substitute x into y as c1, and then separate the variables and integrating. So this is in variable separable form. So separate the variables and integrating. And integration of x cube is x raised to 4 by 4. And the integration, this is the z is the variable, dz means z is the variable, and then z cube plus c1z. The integration is what? Z cube integration is z raised to 4 by 4, and the integration of z is z square by 2. And add the constant of integration, suppose c2 dash, and then multiply by 4 throughout. Therefore we have c1 x raised to 4 is equal to z raised to 4, means minus z raised to 4 minus 2c1 z square, this is z raised to 4, is equal to c2 4 into c2 dash, and suppose 4 into c2 dash is c2. Therefore this is the second solution. That then substitute c1 as x into y. In the last step, substitute c1 as x into y, and therefore we have x into y into x raised to 4 means x raised to 5 into y, minus z square minus 2 c1 as x into y, z square. This is z raised to 4, this is z raised to 4, right here z raised to 4. Then we have this side, sir, minus 2xy z square, and then this first and second forms or gives the general solution of the given differential equation, or is the primitives of the given differential equation, or is the integral curves of the given differential equation. The next example, dx by 1, dy by 3, and dz by x quantity 5z plus tan y minus 3x. So consider first two ratios, dx by 1 is equal to dy by 3. Then we have 3 dx is equal to dy, that is in the variable separable form. Integrating, we have integration of 3 is 3x plus integration of dy is y, and plus constant of integration, either right add c1 dash or c1. And then we have this y minus 3x. 3x minus y is equal to c1 dash. Suppose, and that is y minus 3x is minus c1 dash, and suppose minus c1 dash is c1. So we use the first solution y minus 3x in this the second solution to find the second solution of the differential equation. So consider the second fraction and third fraction. Dy by 3 is equal to dz divided by 5z plus tan y minus 3x, and then substitute y minus 3x as c1. So then what happened, dy, we have dy by 3 dz by 5z plus tan c1. So this is now in two variable y and z. So the variable x cancel because of this substitution, y minus 3x is equal to c1. And then this is in the variable separable form. So integrating both sides. So integration of 1 by 3 dy, integration of 5z plus tan c1. This tan c1 is constant quantity, and 5z is the variable, that is, this is in the form 1 by ax plus b. So what is the integration of 1 by ax plus b? Integration of 1 by ax plus b with respect to x is log ax plus b divided by a. So where a and b are constants and x is variable. So in this integration 1 by 5z means a is 5, z is variable, and times c1 means b. So we have, by using that rule, log 5z plus tan c1 divided by 5 is its integration plus c2 dash, and then multiply by 15. So multiply by 15, 3 5's are 15, so 5y 3 log 5z plus tan c1 plus 15 into c2 dash. Suppose 15 into c2 dash is c2, and therefore 5y minus 3 log 5z, substitute shift this quantity to LHS, and then substitute c1 as y minus 3x, y minus 3x as c1, and is equal to c2. This is second, and then this first, that is this y minus 3x is equal to c1, and this second gives the general solution of the given differential equation. And these 1 and 2 are linearly independent solutions of the differential equation. These 1 and 2 are linearly independent solutions of equation number 1, given differential equation. So the question is what? Find the general solution or find the two linearly independent solution of the given differential equation. The next example, dx by 1, dy by minus z, dz by this quantity. So the basic are two methods. There are two methods. That is, first method is what? In order to solve the differential equation of the type dx by p, dy by q, dz by r, there are two methods. The first method is what? Consider the two fractions. Okay, so either one variable is either absent or cancelled from any two fractions, then consider that two fractions. So the first method is applicable now for this example also, that dx by 1, dy by 3. So consider these two first fractions. So dx by 1, dy by 3, because z variable is absent in these two. So 3 dx is equal to, then integrating, we have this. So also this is the same type example, dx by 1, dy by this is not minus z, this is minus 2, dy by minus 2, and dz by this. Okay, so consider dx by 1, dy by minus 2, right here minus 2, and then separate the variable, 2 dx is equal to minus dy, then integrating, we have 2x plus y. Integration of constant is constant into variable, so integration of 2 with respect to x is what? 2x, and then here is 1 dy, integration of 1 is what? 1 into y, or integration of dy is y is equal to c1. Then consider the first fraction and the third fraction, dz divided by 3x square sine y plus 2x, and then substitute y plus 2x as c1. So this is the sub method of the method number 1. That is, we have this 2x plus y as c1, that is use the first solution to obtain the second solution. So 3x square and this y plus 2x as c1, and then dx by 1 dz by 3x square sine y plus 2x. So substitute y plus 2x as c1, and then separate the variables. We have 3x square sine c1 dx is equal to dz. Then integrating. So this sine c1 is now constant quantity, and integration of x square is x cube by 3. So 3 cancel, and therefore we have x cube is equal to integration of dz is z c2, and therefore we have x square x cube sine c1. So substitute c1 as y plus 2x minus z is equal to c2, and this is the second, and therefore 1 and 2 gives the general solution of the given differential equation. Then next example, find the complete integral of this differential equation, dy by y, dx by y, dy by x, and dz by this quantity. So consider the first two fractions, because z is absent in the first two fractions. Dx by y is equal to dy by dx. Then separate the variables, that is x dx is equal to y dy, integrating x square by 2 minus y square by 2 is equal to c1. That is, if we separate the variables, then integrating, we have the solution x square minus y square as c1. So consider the second and third ratio. Now first and third ratio, dx by y and dz divided by x into y into z square, x square minus y square, and then substitute as x square minus y square as c1. And so we have dx by 1 is equal to dz divided by x z square c1. And then separate the variables. c1 x dx is equal to 1 by z square dz. So separate the variables, and then integrating. We have x, integration of x is x square by 2. Integration of 1 by z square is minus 1 by z, because the derivative of 1 by z is minus 1 by z square. So right here minus sign. Integration of 1 by z square is what? Minus 1 by z, because integration of 1 by z is minus 1 by z square. Or shift this z square to numerator, that is, it is z raised to minus 2. And the integration of z raised to minus 2 is what? Z raised to minus 2 plus 1 divided by minus 2 plus 1. Then again we have the answer 1 minus 1 by z. So we have, this is the second solution. c1 x square by 2 plus 1 by z is equal to c2 dash or c2, and then multiplying by 2, we have this, and then substitute c1 as x square minus y square. So x square minus y square into x square plus 2 by z is equal to c2. This is the second solution of the given differential equation. So 1 and 2 forms the complete integral or general solution of the given differential equation. The next example is dx divided by x, y minus z, dy divided by y, z minus x, dz divided by zx minus y. And now here is the second method is applicable. So what is the second method to solve the differential equation of the type dx by p, dy by q, dz by r? So the second method is what? Find multipliers, or choose the multipliers L, M, N, such that this LP plus MQ plus NR is equal to 0. That is, by trial and error method, find these multipliers L, M, N such that LP plus MQ plus NR is equal to 0. So this method, second method, is applicable for this example. Now the example is what? Dx divided by x into y minus z, dy divided by y in bracket z minus x, dz divided by zx minus y. So choose multipliers 1, 1 and 1. So what happens? If we choose multipliers 1, 1, 1, then what happens? Each ratio is equal to, right? Each ratio is equal to 1 into dx plus 1 into dy plus 1 into dz divided by 1 into this x in bracket y minus z, this 1 into this plus 1 into this, and that is multiplied by 1 1 1, and therefore we have x in bracket y minus z means xy minus hz plus yz minus xy plus zx minus zyz. Okay, and then the addition of these six factors is 0, and therefore we have dx plus dy plus dz divided by 0 means dx plus dy plus dz is equal to 0, and then integrate. So the multipliers are 1 1 1, and then integration, after integrating, what we have, integration of dx is x, dy is y, dz is z is equal to cost of integration is equation number 1. Then again the same method to find the second solution, that is choose multipliers 1 by x, 1 by y, 1 by z. So the first multipliers are 1 1 1, and these 1 by x, 1 by y and 1 by z are linearly independent multipliers of the first. That is, if we take the multipliers multiples of this 1 1 1, then the multipliers are linearly dependent on this 1 1 1. That is, if we take the multipliers as x x x, or 1 by y, 1 by y, 1 by y. So these are the, and then we get the same solution, that x plus y plus z is equal to c1. So these multipliers 1 by x, 1 by y and 1 by z are linearly independent. So in order to obtain the second solution, the second method is what? Choose multipliers LMN such that LP plus MQ plus NR is equal to 0. So similarly here, the second part is what? We may choose another set of multipliers as above, that is choose multipliers LMN such that LP plus MQ plus NR is equal to 0, and the second solution of this, but these two solutions form the general solutions. So we may choose another set of linearly independent multipliers. So write here the word linearly independent multipliers. So this 1 by x, 1 by y and 1 by z is the second set of multipliers. Is the second set of multipliers. So what happen? Multiply, each ratio is equal to 1 by x dx plus 1 by y dy plus 1 by z dz is equal to divide by multiply 1 by x to this factor, 1 by x into x, y minus z, we have y minus z, then 1 by y into y, z minus x, and 1 by z into z, x minus y become x minus y, and therefore we have the answer 0. And therefore 1 by x dx plus 1 by y dy plus 1 by z dz is equal to 0. So after this step, that is right, choose multipliers 1 by x, 1 by y, 1 by z, then write directly this step, that each ratio is equal to. So we have 1 by x dx plus 1 by y dy plus 1 by z dz is equal to 0. Then integrating, what we have? Integration of 1 by x is log x, 1 by y is log y, and then add the constant log c2, and then log a plus log b plus log c is log a into b into c, and therefore we have x into y into z is equal to c2, and this is the second solution, and therefore 1 and 2 forms the general solution or complete integral of the given differential equation. So this is the second method, that is choose multipliers such that LP plus NQ plus NR is equal to 0. The second next example, dx divided by x in bracket y square minus z square, dy divided by this, dz divided by this, and then choose multipliers x, y, z such that each ratio is equal to x dx plus y dy plus z dz divided by multiply by x. What we have? We have this x square y square minus x square z square. Similarly multiply by y and add, multiply by z and add. Then we have answer 0, and therefore x dx plus y dy plus z dz is equal to 0. After integration we have x square by 2, y square by 2, c1 dash. Suppose multiply by 2, we have, this is the one solution, x square plus y square plus z square is equal to c1. Then again the same method to find the second solution of the given differential equation. Choose multipliers 1 by x, 1 by y, 1 by z. And then we have each ratio is equal to 1 by x dx plus 1 by y dy plus 1 by z dz is equal to divided by y square minus z square plus z square minus x square plus x square minus y square. We have the answer 0. And therefore we have 1 by x dx plus 1 by y dy plus 1 by z dz is equal to 0. And after integrating, we have log x plus log y plus log z is equal to log c2. Then log a plus log b plus log c is log a into b into c. And then we have, this is the second solution, that x into y into z is equal to c2. And therefore 1 and 2 forms the complete integral. So for this example, both the solutions are obtained by using the second method, that is by choosing the multipliers. Okay, so we'll see the remaining examples in the next lecture.